we're going to now take this opportunity to talk a little bit about functions. In the overall running of this course, we are going to run into functions at multiple instances. Now, ideally this might not be new, but what a function actually is, and the reason why it's at the top of the order of operations is because a function, such as the one that is here on the screen, is basically a set of instructions. So what f of x is saying here is we're going to take whatever x is and we're going to apply multiple mathematical operations to it. This is why it's at the top of the order of operations. It's actually the most complex thing that you can do with something because it can contain any number of mathematical operations within it. Now, when dealing with these functions, what functions explicitly say is if we apply, say, this function f to a variable x is equal to 3, we actually take the variable that was originally in our function. So these two things are connected. And we do whatever the function says to do. So if we're taking f of 3 here, we're going to do 3 squared, just like we had x squared, plus 6 times 3, plus 6. And if you combine all these together, you're going to get 33. So what you will most commonly see is that when you apply a function to some kind of input variable, you get an output based on some kind of complex procedure therein. Now, we're going to deal with this fairly often because functions are incredibly useful. For the purposes of this course, however, you will see these functions more often than not. And these functions are known as the trigonometric functions. Now, these trigonometric functions, one of them is the sine function, one of them is the cosine function, one of them is the tangent function, and lastly, there is a final function that you will see, which is known as the exponential function. The exponential function here is explicitly a base e to the power of x, but it obeys all the same functional rules that all the other ones do. In fact, the exponential function is also a trigonometric function, but it's one of the few that gets touched on the least. Now, when dealing with algebra, you do not need to know how all these functions are defined. If you take a look at this example, f of x up here at the top, the sine of x actually has a very similar progression of terms. However, it has many more terms, and you're not expected to have to deal with that from first principles. However, you will be expected to deal with this algebraically. So just like in the previous section of dealing with exponents, division and multiplication, and addition and subtraction, there are inverse functions, which are functions that you can apply to whatever you're dealing with to eliminate functions such as sine, cosine, tangent, and the exponent function. Now, these functions, again, are all paired with their inverse function. Each function, whether it's the normal one or the inverse ones that we'll talk about, will actually remove the other one when it is applied to an equation. Now, in terms of these inverse functions, they do have special names, and we're just going to go over what each one is. So, if you have a sine function and you want to eliminate it, the function that you're going to apply to both sides is known as the inverse sine function. Now, depending on the technology that you're dealing with, the inverse sine function is commonly written as a sine of x, or alternatively, if you're using a modern calculator, sine to the negative 1 of x. And I'll move this over so we can see what's going on here. So let's just pull this shorter and we'll move this over. So basically, if you want to eliminate a sine function to get to the inside of it, you're going to apply the inverse sine to each side. Similarly, the cosine has an inverse function known as the inverse cosine function, which I know is incredibly creative. Those of us in physics and math are real good at naming things. But the idea is if you want to get rid of the cosine function, simply apply yourself an inverse cosine function. Likewise, for the tangent function, no prizes here for predicting this. It is eliminated by using an inverse tangent function. And again, the tan to the negative 1 here is not 1 over tangent. It is a completely separate function. Now, last one here, we have the exponential function. This one, however, gets its own name. Exponential functions can be removed by the natural logarithm function, or the ln function. And the idea is you can use these inverse functions just like you could for the inverses of addition and multiplication. and even exponents to isolate variables that are contained in them. And that's going to be a key skill for this course.